Okay, so let's take a look at two triple integrals and spherical coordinates that I asked you to try. So the first one, we've got this integral over the ball of radius 5. If the word ball surprises you, ball can make you think of a sphere. Technically, a sphere is just the actual surface area wrapped around a ball-like shape. When we say ball, we mean we allow every point inside the sphere of radius 5 to also be contributing to this triple integral. So just in case there's any confusion about that. All right, so to describe the ball of radius 5, we'll need to decide a order of integration. I'm going to do rho first. So it's going to go from 0 to 5 because that's the radius. Theta next, 0 to 2 pi to get all the way around the equator in a sense. And then d phi, phi needs to go from 0 to pi so we get the upper and lower hemisphere of the ball. While we're at it, we should convert this. We know this is rho squared and it's being squared, so this ends up being rho to the 4th. So there's our integral, or triple integral. Let's get started with it. Let's just worry about this inside integral for now. So this is the integral from 0 to 5. The integral sign doesn't look too good there. Of rho to the 6th sine phi d rho. Well, rho is the variable, sine phi is just a coefficient, so we don't need to worry about that. The antiderivative of rho to the 6th is rho to the 7th over 7 times this sine phi that's coming along as a coefficient, and we're going to evaluate that from 0 to 5. Unfortunately, we have to do 5 to the 7th power, so that turns out to be 78,125 divided by 7. Sine phi. When we plug 0 in, we can tell that that's just going to go away. So that's the inside integral. The next integral we needed to do, if we look carefully, is for theta. And that's with these limits integration, 2 pi and 0. So integral 0 to 2 pi d theta. We notice there's no theta in here at all. So the antiderivative is just 78,125 sine phi over 7, evaluated from 0 to 2 pi. Oh, sorry. And this gets multiplied by theta. That's my mistake there because the antiderivative of this thing is really just a constant with respect to the variable theta. So it's like taking the antiderivative of 5. If someone says, what's the antiderivative of 5 dx? Well, then you just say 5x. It's the same thing here. It's the antiderivative of some number times, or d theta is just that number times theta. So if we plug 2 pi in for theta, it just becomes 2 pi. 0 would crush the term, so you end up with just this. 2 pi times 78,125 over 7 times the sine of phi. Now we're ready for our last part of our triple integral. Triple integral, we're going to have to do d phi now from 0 to pi. While we're at it, let's make that all into one constant. So 2 times 78,000, sorry about that. My computer's glitching a little bit here. 2 times 78,125 is 156,250 pi over 7, integral 0 to pi, sine phi d phi. The antiderivative there is negative cosine phi, evaluated from 0 to pi. If we plug pi in there, we get negative cosine pi, and then we'd have minus negative cosine 0. That's the negative of negative 1 plus 1, which is just 2. So we get another 2 that we have to multiply this coefficient by. So if we do that, we end up with the final answer of 312,500 pi over 7. So there you are. That's one fun integral to consider.